My name's Steven. I don't have a professional background in mycology. I do work as a naturalist at the Frick Environmental Center over in Frick Park, for those of you who are from the area. And I studied ecology in college. I did take a plant pathology class, which was kind of where I started to fall in love with fungi. So kind of an interesting pathway, just studying like molds that are growing on bell peppers and strawberries and things like that. But that was my first experience, trying to cultivate a fungus and study it and observe it. And from there, I've really just fallen head over heels in love with fungi. But what are they? There's a lot of confusion, and historically they were regarded as plants, right? A lot of people thought since they don't move like animals, they must be plants. They are eukaryotic organisms with cell walls, just like plants, but their cell walls are made primarily of chitin, and unlike plants, they're heterotrophs. And I just really like this picture that shows the tree of life and kind of gives you a sense of where fungi fall compared to animals and plants and some of the other things up there. But yeah, fungi are involved in the decomposition of over 90% of the organic material on Earth, whether that's on land or in the water. So fungi are essential to decomposition and recomposition, right? Making nutrients and other molecules available for other organisms. Yeah, I think right now a lot of taxonomists don't consider fungi a kingdom. It used to be Plantae, Animalia, and fungi. Now I think animals and fungi fall within the Opisthocons here, and that's regarded as a kingdom level classification. Just a little interesting bit of taxonomy there. So yeah, the queendom of fungi is made of at least 120,000 species, estimates of 2.2 to 3.8 million species, and around here you can find at least 3,000 different species of mushroom-producing fungi. Richard, do you know offhand how many different species the club has documented in Western PA?
We're about 1,500.
All right, about 1,500.
Yeah, but I think there's more than that documented, so our list of my list and stuff like that.
Wow, very cool. So yeah, it's a pretty diverse group of organisms, right? And most of these species fall within two main phyla. So I just wanted to quickly review the two main groups of fungi that produce macroscopic fruiting bodies known as mushrooms are the ascomycetes. This is the largest phylum of fungi, which is kind of interesting because if you look at the tables downstairs, we see mostly the other phylum, the basidiomycetes. But the ascomycetes includes basically anything that makes fermented foods or beverages that we like to consume. So all the yeasts, and they're used in a lot of industrial applications for making enzymes, and the basidiomycetes are mostly what we think of when we think of mushrooms, right? So the typical cap and stem mushroom. And so when we get into the microscopy this afternoon, it becomes even more obvious how different these two phyla are, right? So the basidiomycetes, on a microscopic level, their spores are on a club-shaped basidia. The ascomycetes, their spores are contained within a sac known as asci. So they're very different on a microscopic level, just like they're very different on a macroscopic level. But yeah, here's a typical mushroom that you might find with some different features labeled. So if you have been studying mushrooms for a little bit, this is probably common knowledge, but you know, you've got the cap up top. On the underside, you can find a couple different features. This example has gills. We'll be talking more about how they can vary in their fertile surface or their spore-bearing surface. Some mushrooms will have a cup at the base that's called a vulva, and some will have a ring somewhere on their stem known as an annulus. So here's a fun graphic I found that just sort of illustrates some of the different shapes and forms and some of the ways that the gills can be attached to the stem of the mushroom. So I'm going to go over some different morphological groupings, and what I did was I just went through Michael Kuo's key on his website. He has a key to major groups of fungi. So if you take a look on there, if you find something and you have no idea what it is, that's a great place to start, because then it gets you into the right group and you can start figuring out, you know, maybe what family it's in, maybe what genus it's in, and eventually maybe even what species it is. And the interesting thing about the morphological groupings is this isn't taxonomy based, right? Just because these things look similar, it doesn't mean they're related to each other. So it's really interesting if you walk the tables downstairs and see how they're organized. Like, you'll find mushrooms next to each other that look very different, but we know that genetically they share a common ancestor, even though they've arrived at very different forms. So yeah, I'm just going to walk us through this key. And this is a good chance for us to just see how dichotomous keys are organized. When you get further into mushroom identification and we start looking at some of their microscopic features or their chemical reactions, a lot of times you end up working through a dichotomous key to figure out what it is you're actually looking at. And so Michael Kuo's key starts off with, with this one. So you've got two options. Either it's growing on other mushrooms or it's not. And it seems like a simple thing to figure out, right? But sometimes it can be not very obvious, right? This is a cool one I found out at Todd Nature Reserve in the, I think it was in the winter even maybe. And John Plischke helped me identify this. He's really interested in mushrooms that grow on other mushrooms. But when I looked at that, I was like, I have no idea what it's growing on. Is it growing on an insect? Is it like, but yeah, he recognized it right away and pointed me in the right direction. So that made it a little easier for me. But sometimes it's a little more obvious, like on the right there, Talipocladium. When you dig that up, you'll find that the cords, the yellow cords there, are connected to a deer truffle and a Laphomyces species. In the middle there, the Phlebia, it's growing on Sterium mushrooms. So the kind of false turkey tails that you see covering logs sometimes. If you look closely in there, sometimes you'll find these pink growths, and they'll kind of cover old fruiting bodies of the Sterium and grow over top of them. And that can be kind of a clue that, oh yeah, that's growing on another mushroom. But if it's not growing on another mushroom, is where the key takes you. So number 2, you're looking for the presence of gills. So gills are these sharp blade-like structures that you'll find on the underside of mushrooms, and some have what appear to be gills but are not true gills. So the number 3 here kind of tries to separate some things that might appear to be gills but aren't true gills. So if it's growing shelf-like on wood and it's tough and hard and it has gills, then it's actually probably a polypore that's trying to fool you, right? So these are 3 examples of some polypore mushrooms around here that have gills on their underside. So if you saw them from the top, they would look just like most of the other polypores you see out there. When you turn them over, all of a sudden you're like, wait a minute. Yeah. But yeah, feel free to stop me and ask questions at any point as I'm going. Yeah, if any of this is confusing, But yeah, these are just a couple species you can find around here. So if you turn your mushroom over and it's got gills, but it's not growing shelf-like, or it's not tough and woody, and doesn't match that description in number 3A very well, then we go to number 4. So this one divides out some of the chanterelles and their kin from the gilled mushrooms. So here's a couple examples of some of the chanterelle and trumpet species that you can find growing in the area. And these ones will often confuse folks, right? Especially that species in the middle there, Cantharellus appalachiensis. Those appear to be gills, but when you look closely at them, the very tops of them they don't come to a fine point. They aren't sharp blade-like gills that you find on other mushrooms. They're actually kind of rounded and smooth. And yeah, they fit this description up above. They're not easily separable from the cap, and they run down the stem quite a ways. And they're growing out of the soil, not usually on wood. So yeah. Here are some more examples of gilled mushrooms, just to show you some of the diversity in their form. Right, so up top are 3 examples of your standard cap and stem gill mushroom, but often they'll grow in a shelf-like pattern, like the oyster mushrooms here. And you can see on all of these that they have sharp blade-like gills that come to a fine point. And there's a whole bunch of terminology to describe the features of these mushrooms, because this is one of the more diverse groups. There's a whole lot of things within the agaricales and within the russulales, which are 2 big orders of gilled mushrooms. And so when you're looking at these, it's really important that you're paying attention to the details of how those gills are arranged on the underside of the cap. So you can be looking at how they're attached to the stem. Some mushrooms, their gills are totally free from the stem, and some, they're just broadly attached. And there's kind of a spectrum between there. And of course, some do run down the stem, similar to the chanterelles, how their folds run down the stem. So a word you might see to describe gills running down the stem is decurrent, or subdecurrent for ones that don't come all the way down the stem. And then there's a couple different terms for different ways that they can be attached. So adnext, it kind of swoops in a little bit before the attachment point. Adnate just means it's broadly attached. Then you can look at the spacing of the gills. Are they really jammed in there with lots of short gills that don't go the whole way to the stem? Or are they more broadly spaced? And you can look at the very edge of the gill, like if you are holding the cap like flat in your hand and you're looking across the gills, sometimes you can see they've got these very fine serrations to them, and so you can use some of these words to describe the patterns that you see there. Another pattern that isn't up here that a lot of people use to identify some gilled mushrooms is marginate, which just means that it's got a more distinct color on the very edge of the gill than the rest of it. So it might be darker on the very edge. So if you've ever seen the orange mycena, that's a really good example of one that it has really dark gill edges, but the rest of the gills are fairly pale compared to that. And of course, you can't just look at the gills on these mushrooms because they have all these other features that they vary in, right? So different shapes to the base of their stem, to their caps, to the surfaces of the caps. So there's a whole suite of terminology, and these I forgot to pass these out to folks who were coming in late. So I've got these packets. Could you just pass these back to just make sure everyone gets one of those. So yeah, if you're trying to get a picture of these graphics, I just swiped them from this packet I wanted everyone to get a copy of. Yeah. So again, a lot of terminology, and as you're looking through these keys, right, you might start to bump into some of these terms that you're like, what does this mean? What is this huge word? How do I even pronounce this word, right? So it can be really intimidating to folks as they're starting off looking at these. But there's a lot of useful tools out there that can help you make sense of it, right? A lot of field guides come with glossaries. A lot of websites now have really wonderful glossaries. I think even Leon's website has a really awesome glossary with different mycological terminology. So mushroomthejournal.com is another one that you can look at. Michael Kuo's website, again, really wonderful glossary with all kinds of definitions. So a lot of times when I'm working through these keys, I have to look up what these words mean, right? It's not like I read it and I understand it all the time. So a couple steps ago, at number 2, if there aren't gills, then we skip to number 5. So number 5 asks us about if it has pores. So if it doesn't have gills, maybe it has pores. So here are some more examples of polypores that actually have pores. Yeah, some of these are fairly common, right? The resinous polypore on the right, we're going to start seeing a lot of that as we get into the cooler weather. Yeah, a lot of Trametes species. And if there aren't pores present, well, then we've got to go looking at some other groups. Yeah. But even if there are pores present, it doesn't mean it's automatically a polypore, right? Because we have to account for the soft, fleshy pore fungi known as the boletes. So if the stem is attaching centrally and the pore surface doesn't run down the stem, and the spores are not white. So spore prints is a whole other part of identifying mushrooms. And all of the boletes have colored spores. They can be pink or green or brown. But all of the polypores have white spores. So that if you're confused, if you get something and you're not sure if it's a bolete or a polypore, a spore print can be really helpful in distinguishing those. Yeah. So here's a couple examples of some bolete mushrooms. The one on the right is the chrome-footed bolete, which I found up at Cook Forest on Friday. A couple people found that. That's a beautiful one. And if the flesh in the stem is soft, but it doesn't have pores, then I think, wait, maybe I missed one. Oh, if it doesn't have pores, you end up at number 9. All right. So then you look for things that people call teeth. So I've got 2 examples of some toothy mushrooms here. So some of these, when you look at them, will have spines. And this can be really tricky on some of the polypore-like mushrooms. Sometimes polypores, as they age and dry, the pore surface begins to kind of deform a little bit and look more toothy. So it can be a little tricky on those. But a lot of the tooth fungi have very distinct spines on their underside. Or just columns of spines dangling down off of them, like that beautiful Hericium americanum in the middle there that I found up at Cook Forest on Friday. Yeah, there was a lot of Hericium in Cook Forest this weekend. And if it doesn't have spines or teeth, Well, maybe it's a stinkhorn, right? Michael Kuo gave a wonderful talk about stinkhorns yesterday, and I was really ashamed that I only had a couple pictures of stinkhorns in my collection. This is Pseudocolus fusiformis, one of the stinky squid mushrooms that you can find in our area. Yeah, so the stinkhorns are kind of oddballs, but fairly distinct. So covered in some part with a foul-smelling slime arising from a soft underground egg, variously shaped. That's really helpful, right? Maybe it looks like a claw or a lantern or a wiffle ball. But yeah, I think that kind of gives you a sense. For some of this, it's just like, well, you follow one path and you see if it fits, and if it doesn't, you go back and keep working through it. So if it isn't toothy, if it doesn't look like a stinkhorn, well, maybe it's a cup fungus or a bird's nest fungus, right? So if it's got kind of a goblet shape to it, this could be a good group to look at and begin keying out what you're looking at. Yeah, the bird's nest fungi will have little eggs inside of them called peridioles. And, if you're looking at the features of them, noting whether it has a little bit of a string connecting it to the base of the nest can be helpful. Looking at the outside of the nest and the inside and noticing the textures and patterns, right? And on the cup fungi, there are so many different kinds, but I picked two that had some pretty distinct features, some hairy margins. So Microstoma flocosum, very distinct mushroom, and the Scutellinia are very distinct, but they're really hard to distinguish between species. That's one of the groups that you have to do microscopy on if you want to get close to a species, because we have, 20 or more different species in our region.
About 8.
8?
There's over 30 species, but we found 8.
Okay. So at least 8 in our area. And yeah, cool group of cup mushrooms. But there's a lot of other cup mushrooms as well that don't have hairy margins and things like that. So if it's not shaped like a goblet or a cup, well, maybe it's round. Maybe it's a puffball, right? We found a lot of different puffballs yesterday. I know people on my walk found a ton of earth balls, which I didn't put a picture up here of. But yeah, if it's more or less shaped like a ball, maybe it has a stem or not. And when you slice it open, the inside is kind of just a solid mass, then maybe it's a puffball. If it's not quite round and shaped like that, maybe it has a defined stem or not. And that takes us down this rabbit hole of like, maybe it's a weird chanterelle. Right? So now it starts getting a little more complicated. But we're just trying to make sure we stay on track as we figure out which group it is. So maybe it has a weird shaped cap that's kind of brain-like or saddle-shaped or thimble-like. And that would take us to one of the more popular groups of mushrooms, right? The morels and verpas and the Gyromitras. So only really found in the springtime, but a couple different species that grow around here, and they all have that very distinct kind of brain-like cap with a well-defined stem, right? So that's kind of what you're looking for there. And when you slice them open, most of them are hollow or have pockets in them of some sort. Yeah. Any questions about any of these? I was really excited to find the one in the middle there. And Gyromitra esculenta is the name people have been using for a long time, and now folks are starting to think, well, maybe we have another species here in North America. So I saw this name floating around, Venenata, that might be one of the species that we have growing around here. I only find it under pine around here, and that is one that is known to contain the toxic compound gyromitrin. Some people prepare it special ways to consume it, but I would not advise that. Yeah. So maybe it doesn't really look brain-like. Maybe it's got some weird shapes to it. Maybe it's got a fluted stem that has all this weird texture to it. So maybe it's a Helvella, one of the elfin saddles. Or maybe it's another oddball or misfit. There's a whole bunch of different fungi that Michael puts into that grouping on his website. But yeah, then we've got our jelly mushrooms. A lot of different forms to those. Sometimes they're growing out of wood. Sometimes they're growing out of the soil. Sometimes they're shaped like spines. Sometimes they're more round. But they all are kind of squishy and slimy and gelatinous feeling, right? And of course, we've got our clubs and corals, which are a pretty distinct morphological group as well. Some of them might have really fine details at the tips of the spines. So the crown-tipped coral is one that a lot of people learn early on. Pretty easy to distinguish from the other corals based on the multiple points that you'll find at the top. It'll have kind of a cupped top with several sharp points coming off of it. But yeah, we find a lot of different club mushrooms as well, which are just kind of spindles growing out of the ground. They can be different colors, they can grow in clusters or alone. Yeah. And I got kind of tired of putting in all these pictures as I was working on this at 1 in the morning, so I was like, yeah, we'll get to the end and it'll be crusts and other oddballs. Basically, if you get to this far in the key and you haven't found a group that matches, try one of these ones, right? No shade to the crust fungi. They're a really wonderful group of mushrooms as well. Really fascinating to look at under the microscope. And yeah, so that's pretty much how a dichotomous key works, right? Like you look at each pair of questions. Every time there's 2 options, you pick which one matches what you're looking at best, and it tells you where to go next. And there's all kinds of places out there where you can find keys for identifying mushrooms. I put a couple places up here that I've found to be helpful. So Michael Kuo's website is great. iNaturalist and Mushroom Observer are places where you can upload your findings and other people will find them and comment on them. Sometimes people can be really helpful on there. I've had some people link me to research papers when I post something. Sometimes if you search through other people's observations, you can find resources that people have left in the comments. Mycology is a really cool website that I've just begun to explore. They have photos of over 3,000 species of mushrooms that grow in Quebec, and a lot of them happen to grow here as well, right? They're in eastern North America. And yeah, we find a lot of the same mushrooms here, so that can be another great resource. And you can't forget Google Scholar, right? Sometimes if you figure out what genus your mushroom is in, if you're able to work through some of the other general keys and get to a group of mushrooms, then sometimes what I'll do is I'll go to Google Scholar and search, Crepidotus of North America and see what pops up, right? Like I'll plug in the genus name and the location, and sometimes you can find really awesome keys that way that are available and free. Sometimes you have to try a couple links to find the publication, but once you get there, that's where you start coming into a lot more technical terminology, trying to wind your way down to just an individual species, right? The differentiation between species is a lot more nuanced and detailed than the morphological groupings